Hello everyone, welcome to my YouTube channel. So here today we are going to be solving identities. So as you know, our videos are very comprehensive. So in this video we are going to solve all these questions which will equip you to answer any type of identity. So now to begin with, let's begin with our first question. Or before we do that, let's see some identities that are used. So under trigonometric identities, one thing that you need to know is that these are derived from the Pythagoras theorem, meaning to say this one involves numbers that are squares. Like for example, you will find that 5 squared is equal to, we have 3 squared plus 4 squared according to the Pythagoras theorem. Meaning to say, if you say, let's say 5 to the power 3 is equal to 3 to the power 3 plus 4 to the power 3, this is wrong, because 5 to the power 3 is equal to 125 should be equal to 3 to the power 3 is equal to 27, 4 to the power 3 is equal to 64. So if you add these two, you are going to have your 64 plus your 27, which will give you 11, which is 1, remainder 1. 6 plus 2 is 8 plus 1, that's 91. So you will find that 125 is not equal to 91. So I'm going somewhere with this. Likewise, if you look, 3 squared is 9. Here, if you look, 3 squared is 9. 4 squared is 16. 9 plus 16 is 25, which is true for the square of 5 squared is equal to 3 squared plus the 4 squared. So 5 squared is 25, 3 squared is 9 plus 4 squared is 16, like that. So you will find that 25 will be equal to 25. But as long as you change the power to the power 3, power 4, it is not true. Likewise, if you have, let's say, 5 should be equal to 3 plus 4, this is not true. Despite the square being true, but the addition of the individual numbers is not true, because this would be 5 is equal to 7, which is not true. So likewise, under these identities, we are just going to have sine squared theta plus the cos squared theta is equal to 1. So it is only the square. It is only the square that will be equal to 1. Now what this means is that whenever you have the sine of theta plus the cos of theta, this one is not equal to 1. Even if you have the sine to the power 3, sine to the power 3 theta plus the cos to the power 3 theta is not equal to 1, like that. This is what it means. By the way, if I say sine squared theta, this actually means that it's sine theta in brackets to the power of 2. That's the meaning. So this sine cubed theta is the same as sine theta to the power cubed in brackets, like that. So this power is affecting each and everything. So basically, the most important identity that I would just encourage you to know is the sine squared theta plus the cos squared theta, which is equal to 1. With this, we are going to derive most of them without even wasting time. Now, what this means is that what are some of the identities that you need to know? We know that one thing that you should know is the tan of theta. The tangent of theta is equal to, so just know that the tan is associated with sine, so you should say tan is equal to sine of theta, then over the cos of theta, like that. So tan, just remember that it's associated with sine, so put sine on top, cos at the bottom. Now the opposite of the tan is the cotangent. So we have what we call cot theta. Cot theta, which means cotangent. This tan means tangent. This one cotangent, it's the opposite. So if you know that this one starts with a C, what you can do is that on top you put the word that starts with a C, which is the cos of theta over the sine of theta. So it's just the opposite. It is just the reciprocal of the tangent. So in other words, when you just know what the cotangent is, or the cot theta, you can just use that knowledge to come up with a tan to do the opposite. So that is one way you can remember it. Now when we look at other things, we are going to have something like this. Others in other books can write something like the cot of theta is equal to 1 over the tan of theta, because it is the opposite, the cotangent, so it's the opposite, which is still the same as that. We are going to mostly be using this form. So now with that said, let us look at other properties. The sec of theta should be equal to 1 over the cos of theta, like that. So you must know this. So 1 over cos is equal to the sec of theta. Likewise, we are going to have something like the cosec. In other books, they will write it like this: cosec theta, which should be equal to, the cosec theta is the opposite. So if you know what the sec is, just sec is 1 over cos, so the cosec. So if you just think of when they put co, just think of the opposite. So if this is 1 over cos, this should be 1 over sine of theta, like that. So these are going to be used to be able to answer questions. So now back at the identities that we talked about. So we said that the sine squared theta plus the cos squared theta should be equal to 1. Now what this means is that if we have the square here, this will be our first identity. Then the second identity, what we are going to do is we are going to take this. So just know this and those others that I talked about. Say sine squared theta plus the cos squared theta is equal to 1. So in this case, we are going to divide sine squared theta over the sine squared theta. Okay, let's not begin with dividing sine. Let's divide by cos throughout. So it will be cos squared theta. Remember, you have to divide the square over cos squared theta should be over the cos squared of the theta. Now remember what we said. As long as you have sine theta over the cos of theta, this one should be equal to, we said this is tan of theta. So this is the tangent of theta, like that. So already, as long as the powers are the same, this is true. Now we are going to deal with where the powers are not the same, and you're going to understand more. So we have the sine of theta over the cos of theta is equal to the tan squared, in this case, theta, plus cos squared theta over the cos squared theta. We are dividing, so they cancel each other. When they cancel each other, we are going to remain with 1, should be equal to 1 over the cos squared theta. So what is our 1 over the cos squared theta? This gives us a value that will be equal to, remember, 1 over cos is equal to, we have the secant. So we are going to say sec squared theta, like that. So this is the second identity, in which we can use this identity to come up with other things that may be required. Likewise, the third identity will look like this. We have the sine squared theta plus the cos squared theta. This is equal to 1, relatively equal to 1. So what we are going to do is that let's now divide by sine squared theta throughout, sine squared theta throughout, sine squared theta throughout. So we are going to have something like this. This divided by this, they cancel, so we are going to have 1 plus cos squared theta over the sine squared theta. Remember, cos is on top, so this gives us what we call the cotangent, which is the cot of theta, should be equal to 1 over sine is equal to cosec. So if you want, you can write it like this, cosec of theta, or if you want, you can write it like this, whichever is easier for you. So this is the third identity. So with these identities, we are able to solve what we are looking for today. So let's begin with the first question. It says simplify. So let's say we simplify the question, which is the cos of x plus the cos of x times the tangent of, let's say we are just told, times the tangent. squared of x, like that. So how do we simplify this? So we know that, so we have the cos of x, we have plus cos x. We know that the tan of theta is equal to sine, so tan you begin with a sine of squared theta over, we have the cos squared theta, or x in this case. So this is what we have. Now the next step, we are going to have the cos of x plus, we have the cos of x plus, we have sine of squared x. Now this means that if we have cos squared x, it means that we have the cos of x times the cos of x, like that. So we cancel, we are going to remain with cos of x plus the sine squared x over the cos of x, like that. So after doing that, we are going to take this one as our lowest common denominator. Here we have over 1. So we are going to say this will be our cos x. Then on top it will be cos x. We divide first. Cos x divided by 1 is equal to the cos of x. Then this cos of x times the cos of x, it's more like you're multiplying two of them, so it will be cos squared x, like that, plus cos divided by cos is 1 times the sine of squared x is sine squared x, like that. Now we are simplifying, so this will be equal to, remember, cos squared x plus the sine squared x gives us 1. So this is going to be 1 over the cos of x, like that. So if this is the case, we know that as long as you have 1 over cos, this will be able to give you the secant, or the sec of x, like that. So what you can do is that for these identities, you can just write them on the plain paper and just stick them in your room to make it easier for you to remember. And then the next step, the next question says, let's say simplify the cos of, okay, we have already done this. Let's say we have this question, so simplify the sine of theta over the cosec, which can be written like this if you want. As I said, it's the cosec of theta, it's still okay. Cosec of theta, then we have plus the cos of theta over the sec of theta. Let's say we are required to simplify. So how do we do this? So this is the same as sine of theta divide by, that's the meaning, dividing cosec of theta plus the cos of theta divide by our sec of theta. So with this said, that's the meaning, because we know that sec stands for something, so it's better we do it like this. Then what we are going to have is the sine of theta, then this will be divided by, we have the sec is cosec is equal to 1 over the sine of theta, like that. Then we have plus the cos of theta divided by, we have the sec is equal to 1 over the cos of theta. With that said, dividing becomes multiplication, so it will be sine of theta times, immediately we introduce times, it will go up, so we have the sine of theta plus the cos of theta. Then this division will turn into multiplication, and this will go up, so we have the cos theta, like that. So this gives us sine theta times sine theta, it will be sine squared theta plus cos theta times cos theta, this will be cos squared theta, like that. This should be equal to, we know that sine squared theta plus cos squared theta is equal to 1. So we have simplified like that. Let's look at our next question. So let's verify. Let's say we are told to verify the identity of sec theta, cot theta, which is equal to cosec theta. Now remember, under identities, you are going to be picking the most complex side for you to come up with the most difficult one. So in this case, the one that you can choose easily is the one where you have a lot of things. So we are going to choose this side. So using the left hand side to right hand side, we are going to have something like this. So this will be, we know what we have sec theta, cot of theta. We know what sec is equal to. Sec is equal to 1 over the cos of theta, like that. Then we have times, what is the cot? Remember, cot starts with a c, so we are going to put the cos of theta on top over the sine of theta, meaning the tan will be the opposite. So now when we do that, this one and this one are common, so we are going to cancel them. So if we cancel them, we are going to end up with something like this. So here we are remaining with 1, here we are remaining with 1, so it will be 1 times 1, it will be 1 over sine times 1, it will be the sine of theta, like that. Now remembering that 1 over the sine of theta is equal to, what is 1 over the sine of theta? So 1 over the sine of theta, remember, is equal to cosec of theta. So we can say hence proven, like that. So just by doing this, we have proved. Let's look at our next question. We're just verifying now. So verify 1 over the sec squared x is equal to, we have our 1 plus the sine of theta, or rather sine of x, 1 minus the sine of x, like that. Okay, so let's use the right hand side. So using the right hand side, which is this side which has got more of the letters or numbers, so this will give us 1 plus the sine of x times 1 minus the sine of x. So in this case, we are going to multiply. So this means that this first number multiplies everything here. So this is going to give us something like 1, open brackets, 1 minus the sine of x. Then we have plus the sine of x times 1 minus the sine of x. So this now, the second number multiplies everything. That's how come we have sine x times 1 minus the sine of x. So we have 1 times 1 is 1. 1 times negative sine, it will be negative sine x. Sine times 1, it will be sine of x. Sine x times sine x, it will be minus the sine. Then we have the squared of x, like that. In this case, you will find that this is positive, this is negative, so they are going to be equal to 0. So therefore, we are just remaining with 1. Then we have minus the sine squared x, like that, because this and this will be 0. Now, if you recall, the cos squared x, we can say theta or x plus the, so I can say but cos squared x plus the sine squared x should be equal to, we have positive 1. So this means that if this goes this side, it means that therefore the cos squared x is equal to, we are going to have 1 minus the sine of squared x. Now, where is this coming from? So this is coming from, I wanted it to look like this. So from that identity, it means to say wherever you see this, you must put this. Therefore, it will be the cos of cos squared x, like that. So this is what we have as our last thing. But the identity requires us to prove that the 1 over the sec squared x is equal to that. So therefore, we need to use this to come up with the answer. Now what we are going to say, if we know that the sec squared x is equal to 1 over the cos squared x, remember the sec is associated with cos, so we are going to have something like This means that to make cos the subject of a formula, this will be equal to, we have this times this, it will be sec squared x times the cos squared x should be equal to 1 if this and this multiplies. Then you divide your sec squared x, you divide your sec squared x. So as you can see, cos squared x is equal to 1 over the sec squared x, which is as required. So as required, you can put hence shown like that. So this is just something that we use the right hand side to be able to come up with this side. Even if you were to use this side, it would still come out. Like for example, if we use the other side, we can say 1 over sec squared x. Now knowing that we have already derived it, cos squared x, we have said that it is equal to 1 over sec squared x. So therefore, where you see 1 over cos, you can put cos squared x like that. Knowing fully well that the sine squared x plus the cos squared x is equal to 1, when this goes there, it will be equal to cos squared x is equal to 1 minus the sine squared x. Now from here, what you can do is this. So already wherever you see cos squared x, you put this. So it will be 1 minus the sine squared x like that. So you can square 1. 1 squared is still 1. Then this forms your difference of 2 squares. So this is the same as 1 squared minus sine x times the sine of x. So this means that this is the same as 1 minus, remember the difference of 2 squares, it means 1 minus the sine of x times, the other one will be 1 plus the sine of x. That's the difference of 2 squares. If you recall, 1 will be negative, 1 will be positive. So this could be how you can derive that. You can say hence shown. So it doesn't matter the side that you pick, but I would encourage you to be picking the complex side because it's much easier. Let's verify this. Let's say we have the sec x minus the cos of x should be equal to the sine of x by the tan of x like that. So how do we verify this? So let's look at this one. Wherever you see minus, plus, it's much easier to work with it. So let's deal with this one. Let's use the left hand side. We are going to have the sec of x minus the cos of x. So remember, when you're dealing with the sec is the same as 1 over the cos of x like that. Sec is 1 over cos minus, we have the cos of x like this. So then what are we going to do now? Let's use this one as our lowest common denominator. So we are going to have the cos of x. Then cos divided by cos is 1 times 1, it will be 1. Then we have 1 minus, we have cos x divided by 1 times cos, it will be cos squared x like that. Now if you recall, 1 minus the cos of x is equal to sine squared x. By now you should be able to remember sec squared x plus the cos squared x is equal to 1. So that means to say, if I have this going at the other side, it will be sine squared x is equal to 1 minus the cos squared x like that. So this will give us 1 minus this, it will give us sine squared x over the cos squared x, or over the cos x like this. So this means that we can separate it by saying this is the same as sine of x times the sine of x. Now there is only one cos of x. Now if this is the case, it means it will be like this. If it was squared, it could have been squared. But since it's just 1, it will be like this. Sine over cos will give us the tan of x. Then we have times the sine of x like this. So this is the answer. We can say hence shown like that. So this is the answer for the problem. Let's say we have the cos of x plus the tan of x over the sine of x cos of x. This one is equal to the cosec x plus the sec squared x. Okay, let's use the left hand side. So what are we going to have? In this case, we are going to have, let's say if you have 2 over, let's say 4 plus 3 over, let's say 6. Okay, let's say 4. Like this. So if you have such a number, the common denominator is 4. Then what will be on top is 4 divided by 4 is 1 times 2. It will be 2 plus 4 divided by 4 is 1 times 3. It will be 3. So now as you can see, 2 over 4 plus 3 over 4 is the same as this. So this means that this can be written as 2 over the same number 4 plus the 3 over the same number 4, which is still true. So we are going to use that principle when answering such a question like this one. So with that said, we are going to say this denominator divides everything. So this is the same as having the cos of x over the sine of x cos of x plus the tan of x over the sine of x. Then we have the cos of x like that. So what answer are we expected to produce? So the answer is this. So with that said, what we are just going to do is let us just divide. So already what we can see from here is this and this goes. So we are remaining with 1 over the sine of x. Then we have plus the tan of x. What are we required to have? So we are required to have the sec. So it means to say we are going to have the tan of x like that. Then divide by, that's the meaning of over. We have the sine of x cos of x like that. So this gives us 1 over sine x is equal to cosec. Remember, so we have the cosec of x. Then this gives us our plus tan of theta is sine theta. In this case, sine of x over the cos of x. Then we have times. So multiplying means it will be 1 over the sine of x cos of x like that. So this one and this one goes. This gives us cosec of x plus, here we have 1 by 1, it will be 1 over cos by cos, cos by cos, it will be cos squared x. So this gives us cos squared x like that. This gives us the cosec of x plus 1 over cos of x. This gives us our cosec, oh sorry, not cosec, but sec squared x. So 1 over cos is cosec, sorry, sec squared x. So this is the required answer. So you can say hence proven. So you're just playing around. So one thing about identities is that just don't overthink. Just go with the flow. Don't take shortcuts and everything will be well. So in this case, let's look at our next question. Looking at this question, cos of x over 1 plus the sine of x plus cos x over 1 minus sine of x is equal to 2 sec x. So how do you deal with this one? So looking at this, we are going to choose the left hand side. Why? Because it's more complex. So choose the complex side. So you have the cos of x over 1 plus the sine of x like that. Then we have plus the cos of x over, we have 1 minus the sine of x like this. So if you recall, First, let's find the common denominator, which are both of these. So it will be 1 plus the sine of x times 1 minus the sine of x, like that. So this gives us, since we are this divided by this and this will cancel. So this is the same as if you take both as your common denominator, you just need to multiply this with this with this, you multiply diagonal. So this will be cos of x times, we have 1 minus the sine of x, then we have plus our cos of x will multiply with this, so we have the cos of x, then times our 1 plus the sine of x, like that. So this gives us cos times 1, cos of x times 1, it will be cos of x, cos times negative sign, it will be minus, okay, let's not do that, I've seen something that is easier. So as you can see, we have plus, these two are separated by plus, and this one are the same. So let's just factorize. So factorizing this means cos of x, we are going to take it cos of x, then what is remaining here is 1 minus the sine of x. Then here, since we have factorized, what is remaining is this one, so we are going to say positive 1 plus the sine of x, like that. So over, what do we have? Remember, according to conjugates, if the numbers are the same but the sign is different, you just multiply first number with first number. So 1 times 1 is 1, last number with last number, so the sine of x times the sine of x. Now since there is minus, we are going to say minus sine x times sine x, it will be sine squared x, like that. So this gives us, we are going to have the cos of x, open brackets, then we have 1 plus 1, it's a 2, negative sign plus positive sign is 0. So we are going to have positive 2 over, we have 1 minus the sine squared x. Now remember, cos squared x is equal to 1 minus sine squared x. If you do your cos x, cos squared x plus sine x squared is equal to 1. So that means to say, here you are going to put cos squared x. So we have our cos of x on top by the 2, then we have over 1 minus sine squared x is equal to cos squared x, like that. So this gives us our cos, 2 by cos, it will be 2 in front, 2 cos x over, we have cos squared x is the same as cos x times cos x. So this one and this one goes, so this gives us our 2 times, if you want you can say 2 over cos, but just to make you understand, this is the same as 2 times 1 over the cos of x. It's not different if someone says 2 over cos of x, it's still okay. So we have 2 times, what is 1 over cos? 1 over cos is equal to sec x, like that. So this is our answer as expected. So we can say hence shown. For some of you, as long as you have even failed the question, you will just write hence shown. Let's look at our next question. Let's look at this question. So we have cos x over 1 minus sine of x. So here we can, let's use which side. We can use any, but I was just trying to look at which one would be most practical to use. Okay, let's use the right hand side. Even the left hand side, it's okay. Even the left hand side is okay. Let's use the right hand side since we have been using the left hand side too much. So we have 1 over the sine of x, or 1 plus sine of x over the cos of x. So now in this case, the only way you can reach 1 minus sine is if you have the identity cos squared x plus the sine squared x, like this, should be equal to 1. So in this case, how do you create the cos squared? You square both sides, or should I say not squaring, but you multiply the cos on both numbers. So you are going to say cos of x, like that, even on top the cos of x, like that. So this means that we are going to have our So just be careful. This will be outside the bracket, so it will be cos of x, open brackets, 1 plus the sine of x, like that. So over, we have the cos x times the cos of x is cos squared x, like that. Now remember the identity for cos squared x. So we have cos x on top. Here we are going to have 1 plus the sine of x. Others might want to divide here, but if you divide there, that means you haven't done anything because you introduced the cos on top. So over our cos squared x, we said that it is equal to 1 minus sine squared x. Remember this identity. We have derived it, just taking the sign the other side. It will give you this. So we have the difference of two squares. This gives us, we have the cos of x, open brackets, 1 plus the sine of x, over, we have, this is the same as 1 minus sine of x. Also, we have 1 plus, that's the difference of two squares. We have already done a similar thing. Now, what you can see is that this and this are common, so we can say this and this cancel each other. When these cancel each other, we are going to remain with our cos of x over 1 minus the sine of x. So you can say hence shown. If you want, you can use this other side. So using this side, we are going to say, as you can see, this is 1 plus sine of x. Let me just lift this. So using this side, what are we going to do? So already, if we want it to give us 1 plus sine x, it means to say we need to introduce the conjugate. So if we have 1 minus, here we are going to have 1 plus the sine of x. Here we are going to have 1 plus the sine of x. Remember, we multiply conjugates, same things but different signs there. We just multiply same number or first number with first number. So on top it will be the cos of x, open brackets, 1 plus the sine of x. At the bottom it will be 1 times 1, first number with first number is 1, then last number with last number, negative sine of x times positive sine of x, it will be negative sine squared x, like that. So this gives us we have our cos of x by 1 plus the sine of x over 1 minus the sine squared x is equal to the cos squared x. And cos squared x, without wasting time, is equal to cos x times the cos of x. So this and this goes. So this gives us 1 plus the sine of x over, we have the cos of x. So we can say hence shown, like that. So we have derived the other side as well. So whichever side is okay, depending on which one you are conversant with, will determine what you are going to answer. Let's say we have this one. So again, let's use the left hand side. So this gives us our tan of x plus the cos of x over the sine of x. So this should be equal to that. So remembering, this is the same as the tan of x over the sine of x plus the cos of x over the sine of x, which should be equal to, so in this case we can split this equation by saying tan of x, this is the same as divided by the sine of x. Now remember, cos over sine is the one that starts with the is cot of x, like that. Then tan of x is equal to sine of x over the cos of x. Then division becomes multiplication, so it will be times 1 over the sine of x. So this one and this one cancels. So here we have plus the cot of x, like that. So this gives us 1 over the cos of x plus the cot of x. 1 over cos gives us sec x, like that, plus we have the cot of x. So this is our answer. So you can see that this is the required answer. So we can say hence shown. So our next question, which is number 33. Our next question, which is saying that cosec, which can be written as cosec. If you want, you can write it in full. So cosec x sec x is equal to tan of x plus the cot of x. So immediately you say plus, it's better you deal with that side. So let's use the right hand side. So this gives us our tan of x plus the cot of x. So remember, tan is associated with sine, so you can say sine of x over the cos of x plus cot is associated with the cos on top, so we have the cos of x over the sine of x. So this gives us sine over cos, gives us the tan. From here, what we are going to do is that we are going to find the lowest common denominator. So finding the lowest common denominator, it's both of these. So we are going to combine them by saying cos x sine x, like that, then divide them. So if you take both of them, it's the same as this multiplies that. So we are going to have sine times sine, it will be sine of sine squared x. Cos times cos, it will be cos squared x. So adding the square of these will always give you 1 over the cos of x sine of x, like that. So this gives us our 1 over the cos of x. Then we have times, so the 1 can be divided, 1 over this can be split, sine of x. This is not only allowed if you have, let's say, 1 over sine x plus the cos x. This is not allowed where you say 1 over sine of x like this plus 1 over cos of x. This is something different. But if they are connected by multiplication, you can do this. You can do this. So 1 over cos is equal to, we have the sec x, then we have times 1 over sine is the cosec x. Now just to write the way they have written, let's begin with this one. Cosec of x times the sec of x, like that. So this is the required answer. So we can say hence shown. Let's look at our next question. Let's look at this question. So this one, we are going to look at the right hand side. It's more complex. So the right hand side is cot of x, open brackets, 1 plus the tangent, the tan squared x, then we have over our 1 plus the cos squared x, like that. So now, provided with this question, let's be able to answer. Did we write cos here? It's cot squared x. So now whenever you look at something like this, identify your identities. So according to your identities, if we have sine squared x plus the cos squared x should be equal to 1. If we divide our sine throughout, it will be sine squared x over the sine squared x over the sine squared x. This gives us sine over sine is 1. Then we have plus cos over sine. As long as cos is on top, we are going to call it the cot. So we have cot, or cot squared x should be equal to 1 over sine is equal to cosec, which can be written like this, cosec squared x, like this. So this is the identity. So already this is equal to what we call cosec already. Then the other identity that we can have is if we have sine squared x plus the cos squared x, this one is equal to 1. When we divide our cos squared x when we divide our cos squared x, cos squared x, we are going to have sine over cos. This gives us the tan squared x plus cos divided by cos is 1, so we have 1. It's more like they are cancelling. Should be equal to the sec squared x. So wherever we see this, we are going to put sec. The other identity that we have just written is this 1 plus the cot squared x should be equal to cosec squared x. So now with this, we can prove the identity taken from here. So the next question says we have the tan of x is equal to the cot of x, open brackets, 1 plus the tan squared x over, we have the 1 plus the cot squared x. So remember, we have derived these identities. So we have the, let's pick the right hand side. So according to the right hand side, whenever we said that whenever we have 1 plus the tan squared of x, this should be equal to the sec squared of x. Then our 1 plus the cot squared of x, this is equal to the cosec squared of x, like that. So wherever we see this, we are going to put the cosec. Whenever we see this, we are going to put a sec, like that. So this gives us, we have the cot of x by, we have 1 plus the tan squared of x. 1 plus tan squared of x is equal to sec. So we are going to have sec squared x over, we have 1 plus the cot squared of x is equal to the cosec squared of x, like that. So then let's deal with this. So this gives us our value, which is cot x is equal to the cos of x over the sine of x. Then we are going to have multiplied by, this is the same as the cos sec squared x. Then we have times division, divide by cosec squared x, like that. So this gives us cos of x over the sine of x. Then we have by our sec squared x, this is the same as cosec is the same as we have 1 over the sine squared of x, like that. So by doing this, let us simplify things now. So simplifying things, we are going to get, this is the same as cos of x over the sine of x multiplied by the sec of x is the same as 1 over the cos of x. Then we have multiplied by, immediately we introduce multiplication, this goes up, so we are going to have sine squared x, like that. So this is the same as the cos of x over the sine of x, then multiplied by 1 over cos x is equal to cos of x times the cos of x, like that. Then multiplied by our sine of x is the same as sine x by the sine of x, like that. So this one and this one goes, then this one and this one goes. So we are going to remain with 1 by sine of x. It will be sine of x over the cos of x. So sine x over the cos of x is equal to the tan of x. So we are going to get tan of x, and that is our answer. So we are going to say hence proven. Let's say we have this one. So again, let's pick the left hand side. So picking the left hand side, this is going to give us, we have our tan of x minus the sec of x. Then we have our squared, like that. So tan is the same as sine of x over the cos of x. minus the sec is the same as 1 over the cos of x, like that. Then we square like that. From here, pick the lowest common denominator. So the lowest common denominator is equal to, we have the cos of x is the lowest common denominator. Cos divided by cos is 1 times sine. It will be sine of x, minus cos divided by cos is 1 times 1. It will be 1. Then we have our squared like that. So this squared can be distributed. So we are going to have sine of x minus 1. We square this over the cos squared of x, like that, because this is affecting everything. It comes there, it comes here. That's the meaning. So with that said, as you can see, we want 1 minus sine of x. Now remember, the cos squared x is the same as 1 minus the sine of x. Cos squared x is equal to 1 minus sine squared x. So this gives us our sine x. This is the same as sine x minus 1, sine x minus 1. Then we have over 1 minus the sine squared x, like that. So this is a difference of 2 squares. So we are going to have the sine x minus 1 by our sine x minus 1, then over, this is the same as 1 minus the sine of x. The other one will be 1 plus the sine of x, like that. So this will give us, so already we can see that this is 1 minus sine, this is sine minus 1. So let's change the numerator, if you want the denominator or the numerator, by factorizing negative 1. So if we factorize negative 1, it will be negative 1, open brackets. This will become negative sine of x. This will become negative divided by negative is positive 1. Then we have the sine of x minus 1, like that. Then we divide our 1 minus the sine of x, like that. Open brackets. We have 1 plus the sine of x, like that. So with this done, we are going to write its property. So it will be 1, open brackets, 1 minus the sine of x, close. We open another one, it's sine x minus 1, like that. Then we divide by 1 minus the sine of x, like that, by our 1 plus the sine of x, like that. So this one and this one goes. We're going to have negative 1, open brackets, sine of x minus 1 over 1 plus the sine of x. Opening the bracket, negative 1 by the sine of x, it will be negative sine of x. Negative by negative, it will be positive 1 over, we have 1 plus the sine of x, like that. So writing property, it's 1 minus the sine of x over 1 plus the sine of x. Is this the required answer? 1 minus, then down here it's positive. So we can say from here, hence shown, like that. So this is what we have as our answer. Let's move on to our next question. Let's say we have this next question. Says that the sine of theta plus the sine theta tan squared theta should be equal to tan theta. Then we have the sec theta, like that. So from here, let's use the left hand side since it is more complex. So we have the sine of theta plus the sine of theta tan squared theta should be equal to tan of theta sec theta, like that. So what we are going to do from here is, let's just factorize the sine of theta. So sine of theta is common. We are remaining with 1 plus the tan squared of theta. Then this should be equal to tan of theta sec theta, like that. So this gives us, not equal to, but we are proving. So from there, what we are going to have is 1 plus tan squared theta is equal to sec. So how you can remember these identities, that you know that the tan is equal to sine theta over the cos of theta. Sec is 1 over cos of theta. So since these have got similar things, so just know when you add 1 plus the tan squared of theta is equal to sec squared theta. So that is one way you can be remembering. So we have the sine of theta, but the easiest way is to derive it like as I was doing in the previous minutes. So we have the sec squared of theta like that. So this gives us the sine of theta by 1 over, the sec is the same as 1 over cos squared of theta, like that. So with this is the same as the sine of theta divided by the cos of theta by 1 over the cos of theta. So that when I multiply cos theta times cos theta, it will be cos squared theta. In this case, sine over cos is equal to, we have the tan of theta, then we have 1 over cos is equal to sec of theta, like that. So this is our answer, which is as shown. Where is it? Which is as required. So you can say hence shown. Let's try to prove this one. So power 4, immediately this one is more complex, so we are going to use the left hand side. So this is going to be tan to the power 4x minus sec x to the power 4. So this one already, this is the difference of two squares, so this can be expressed as tan squared x, then we have the squared, so that this square and this square will produce 4. So we have minus the sec squared of x, then we are going to have power like that. So using this difference of two squares means that one will be tan squared x minus, both have squares, minus the sec squared x, then the other one will be plus, that's the difference of two squares, the other one will be plus, so it will be tan squared x, then we are going to have plus the sec squared x, like that. So this is the difference of two squares. Now remember, we said that sine squared x plus cos squared x is equal to 1. That means for me to produce sec, I need to divide my cos squared x on all the numbers. Cos squared x. So sine over cos is equal to tan squared x plus cos over cos is 1. Should be equal to 1 over cos is equal to sec squared x, like that. So with this done, we are going to have our value, which will be equal to, so already tan squared theta minus sec squared theta is the one that will be equal to -1. So what we are going to do is that tan squared theta plus sec squared theta cannot be produced. So what are we going to do? We are going to take this sec this side and this value this side. So this will be tan squared x minus sec squared x should be equal to this -1 when it, this +1 when it goes this side, it will be -1. So that means to say wherever you see this, you put -1. So wherever you see this, you put -1. So with that said, we are going to have something like this. It will be -1, open brackets, tan squared x plus the sec squared x. What are we required to produce? So we are required to produce 1 minus 2 sec squared x. So meaning to say we are not interested in tan. That's the meaning. So we need to know how we are going to eliminate that. So let's first multiply throughout, or we can deal with what is inside. So we need to produce sec. Tan has to go. Remember, tan squared theta is equal to, so in terms of sec, if you look at this, it means to say when you take the -1 this side, it becomes -1. Tan will be equal to this. So tan will be equal to sec squared x minus 1. So this will be sec squared x minus 1 plus the sec squared x, like that. So we have -1 sec squared x plus sec squared x. It will be 2 sec squared x minus 1, like that. Then multiply everything. -1 by 2, it will be -2 sec squared x. Negative by negative, it will be +1. So this is the same as +1 minus 2 sec squared x, like that. So this is our answer. So we can say hence shown. Let's look at this one. Picking the one with a minus at the denominator, we're going to say the left hand side. So it will be the tan of x over, we have our sec x minus 1. So now the only way you can provide or produce a tan is if this is a squared. Remember the identity. So what we are going to do is introduce the conjugate. So it will be sec x plus 1. Even here, sec x plus 1, like that. So in that case, what we are going to have is a tan of x, open brackets, sec of x plus 1. Then over the first number, since they are conjugates, multiplies with the first number. So it will be the sec squared x. The last number multiplies with the last number. So it will be minus 1, like that. Now remember, the identity is such that we have 1 plus the tan squared x is equal to sec squared x, like that. So this means that when we take this -1 this side, it will be tan squared of x is equal to sec squared of x minus 1. So wherever we see that, we're going to say tan squared of x. So this will be tan of x. Then we have open brackets, open brackets. So we have sec x plus 1. Then we divide. The bottom will be tan squared of x. In this case, there are 2 of the tans, so the power will cancel and this will go. So we are remaining with sec x plus 1 over the tan of x. So we can say hence shown. So that's all for this video. I hope it was helpful, and see you in the next tutorial where we are going to solve questions dealing with equations. Kindly like, subscribe, and share for more. See you in the next tutorial.